In this video, we want to sketch the graph of y equals 3 times sine of 2x for a given domain or a given interval, which is negative 180 is less than or equal to x is less than or equal to 180. So whenever we want to sketch a sine or even a cosine curve that's in this form, so a number multiplying sine of 2 times x or a number times x, two things we want to find out are the period and the amplitude of the function. So if we start with the amplitude, we simply look at the number that's multiplying the sine function, and that will tell us that the amplitude is equal to 3. So that will tell us how far above and how far below the center line this function will reach. And the center for this is going to be when y is 0, or it's going to be this x-axis. The next thing we do is we look at the coefficient of x, or the number multiplying x, and this is what we're going to call n is equal to 2, and that relates to how we calculate the period. So the period, as a formula, is 360 divided by n, where n in this case is 2. So our period is going to be 360 divided by 2, which equals 180. So that tells us how long it takes for this graph to complete a full cycle. So because it takes 180 to complete a full cycle, and we go from negative 180 to 180, that'll fit 2 full cycles of a sine curve. Now, sine and cosine have some basic shapes that we need to be aware of. And there's no reflections that are taking place, so we know the basic shape of a sine curve. So the sine curve starts at 0, 0. It will go up, down, and back up to complete one cycle. So we know that the period is 180, and we're going to start at 0 and trace out the first cycle of this graph, which is going to go from 0 to 180. So the graph's going to look something like... So we now have one cycle that goes from 0 to 180 degrees. We're also going to have a second cycle that comes out here that goes from negative 180 to 0. So let's have a go at sketching that on. So we're going to have something like this that joins on. Now it's not perfect, but it's not a bad attempt for a by hand graph. And we now have the graph of 3 sine of 2x between negative 180 and 180 degrees. And our last job here really is just to put all the key features on it. And that'll include a scale for our axes. So if we start there, I might do this in the pink. We're going to have, this is going to be minus 3, because that's how far below the center of the function or the graph it will reach, and that's related to the amplitude. And this value up here is going to be positive 3. Now, we also knew that we started the graph, so we're going to have a colored in dot back here, at negative 180, 0, and that the graph finished, and we're going to have another colored in dot here, at positive 180, 0. And then the other key features we have are 3 more x-intercepts, a couple of maximums, and a couple of minimum turning points. So if we keep going with our x-intercepts at this point in time, this is going to be halfway between negative 180 and 0. So that's going to be negative 90, 0. This point here, which is at the origin, is going to be 0, 0. And this point here is going to be 90, 0. Then we've got our maximums, where we know that they have a maximum value of 3. But the x value is what we still need to work out. So luckily for sine and cosine, our maximums occur halfway between these x-intercepts. So halfway between negative 180 and negative 90 is going to be negative 135, positive 3. And then up here we're going to have halfway between 0 and 90 is 45, 3. And then we're going to have down here, this is going to be 135, negative 3, and our last key feature that we'll label is going to be negative 45, negative 3. So that's our full sketch for y equals 3 sine of 2x. And what we're going to do now is we're just going to take a moment to do this on the calculator so that you can see how that would be done. So on our calculator, we're going to go into the main menu. Then we're going to type in our rule. So we're going to bring up the keyboard and we're just going to type in 3 sine of 2x. So 3 sine of 2x. And then we're going to hit execute. We're going to bring up the graph screen and drag that down. So we're going to drag that down and we don't get a particularly good view of this graph. At the moment it looks almost like a straight line, and that's because we need to adjust our view screen to capture the whole graph. So we're going to click the 4 arrows up the top and we're going to go from negative 180 to positive 180 for x, and that's because the domain or the interval that they wanted it sketched over is given to us. And for our y min and y maximum, negative 4.6 and 4.6 isn't bad. I'm just going to make it negative 4 and positive 4. And that should give us a nice, good look at this graph. Now we can use the analysis GSolve menu to find all of these key features. So if we start with analysis GSolve root, it will give us all of these x-intercepts. So negative 180, 0, and I can hit execute to lock that on. Then I'm going to use the right arrow to go across to the next one, which is negative 90, 0, and then across to the next one, which is 0, 0, and then the next one, which is positive 90, and the last one, which is 180, 0. Then we can go analysis, GSolve, and we could do the maximums next by hitting max, and we're going to get negative 135, positive 3, and we're also going to have, if we use the right arrow to tab across, 45, 3, and then analysis GSolve min, and we can see we get down the bottom negative 45, negative 3, and we also get 135, negative 3. We can lock that point on by hitting execute. So we've now got a good look at our graph on the CAS calculator, and we can see that it is exactly what we made by hand. So that's how we can sketch the graphs of sine, and cosine is similar, by hand and using a CAS calculator. Stay tuned for more videos that will go over more examples of sketching sine and cosine graphs. And finally, good luck with any problems that you are attempting.